So today we're learning about walking rainbows. Before we begin, do you guys know primary colors? What are the primary colors? There's lots of colors out there, but what are the primary colors? Give you a hint. There are 3 primary colors. Primary colors. Okay.
Says there's 2 people, so
Primary colors.
no comments yet.
Are red, yellow, and blue. What happens if you mix colors together? If you were to mix colors together, are you still going to have the original color, or do you have a new color? You actually are going to get a new color, and these are secondary colors, and that's what we're going to see as well with our walking rainbow. So let's get started. You should have received the supply list. It was posted, I think, last week, so you should have everything you need. We need 6 clear glasses, some water, and some food coloring, and paper towels. So we're going to go ahead and get started. We're going to learn about forces today. So stack your cups up into a circle. There we go. I'm going to flip my notes here. Okay. So now we're going to fill all the cups up about 3/4 of the way full. So I have little lines on my cup, so I'm going to go up to here. You can use plastic cups, glass cups. Those are probably the 2 main materials you would be using. Just make sure they're clear. You can also do this with opaque or non-clear glasses, and it will just be harder to see the color change, so you'll have to look at it head on versus you can see it through the cup. So we're going to go ahead and fill these up. Only 3 of them. You do not need to fill all of them up, and you're only filling up every other cup. So we're going to fill up 1, skip 1, fill up 1. So.
Okay, someone just gave the thumbs up.
Awesome. Maybe comments are working. We got a thumbs up. We like that. So we'll see if we get more comments. I ran out of water, so we're getting some more water here. I'm going to continue.
Now it says we're down to 1 person.
I think we're having connection issues. So if not, we'll catch them up on the replay. As we see comments, we'll read them. If we have people live. So we have 3 cups. Again, we have 1 cup with water, empty cup, water, empty, water, empty. So we're going to go ahead and take our primary colors that we discussed. Before I begin, we are using food coloring. This dyes your clothes, counters, whatever. So I laid down newspaper for my surface. I recommend putting something down if you don't want something to get accidentally destroyed. So we're going to start with the red food coloring. We're going to add 4 drops. So 1, 2, 3, 4. Put the cap back on. You can also wear gloves if you don't want it on your hands. I was rocking some blue earlier. Yellow is next. We're going to do 4 drops of yellow. 1, 2, 3, 4. And then we're going to add 4 drops of blue. 1, 2, 3, 4. So we're going to let those sit. Eventually the color will completely disperse and we'll have you can kind of see it still working its way through, but eventually it'll be all one color. So we have our primary colors, red, yellow, blue. Now we're going to cut up some paper towels. You want to make sure your paper towels are long enough to go from one cup to the other and touch the bottom. So, let's see here, how's this? This does not go to the bottom, so that's too short. This is a little bit long, so we could probably cut it a little bit, but it'll be okay. So I need to cut 6 strips. Another option you can do, if you don't have scissors and you don't want to cut, you can take this, fold it to the halfway point, fold this up to the halfway point, and then fold it in half to make like a 1-inch strip. So you can do that, or you can cut it. So I'm just going to cut mine real quick. So we're just cutting paper towel until about 1-inch strips. It doesn't have to be precise. I promise, because my cutting is not very precise. And you need 6 of these. So then we're going to cut some more. That one may have been a little bit less than an inch. Okay. So here we go. We have some strips of paper towel. You're going to start by putting 1 strip into the red. I like to get it a little bit, get it in there a little bit so it's at least wet across the bridge. Otherwise, your paper will fly out. And then you're going to take your second piece. You're going to dip it into the yellow. And then you're going to bridge it over into the empty cup. See how if you don't get it wet, it kind of flips back. So there we go. And then we're going to go yellow into this empty cup between the yellow and the blue.
Oh, Sharon joined. Sharon from Cincinnati is watching.
Yeah, hi Sharon. Thanks for joining us. And then we're going to do the blue into the empty cup. Here. And then we're going to take blue into this empty cup. Just kind of fold it over. And then last but not least, we're going to go from red into this empty cup. So here we have our experiment set up. We have our 3 primary colors as we discussed earlier, red, yellow, and blue. And then we have our 3 empty cups. We discussed that mixing these together create new secondary colors. So we're going to learn about color mixing. So red and yellow, so we have red and yellow. When we mix those 2 together, we're going to get a new color in this cup, the empty cup. When you mix red and yellow, what color do you think you all get? I promise you know this color. When you mix red and yellow together, wait for it, you get orange. You get the color orange. So, as the water is traveling, we should get orange in this cup. Next, we have blue and red. As you can see, we have blue and red, so eventually we're going to get a new color in here. What do you think it's going to be? It's a very pretty color.
Marcia from Cincinnati is watching now.
Hi Marcia, welcome, thanks for joining us. Purple, so when we mix blue, this is blue, and red together, we will get purple in this cup.
Oh, Marcia says she got in the 1 p.m. live video by mistake at first.
I bet that's going to cause people problems. So if you're just joining us, we had a little bit of a technical glitch in the beginning where people were joining, people weren't joining, we couldn't see comments. So hopefully we're able to see comments. It seems like we are. We just got started mixing, putting everything together, so if you missed it, we can always catch you up in the replay. Right now we're talking about mixing of colors. So we have the yellow and the blue. So when these 2 mix together, we're going to get a new color. So when we mix yellow and blue together, you get green, Girl Scout green. So we'll keep an eye on this cup and see if we get green in there. So how do you guys think water is getting from one cup to the other cup? Because as you can see, we're already getting some water collection in these cups. We have a little bit in this cup, and we have this cup's getting some. See, it's almost turning green. So how do you think water's being transferred from one cup to another? You might say paper towels, to which you're right, but what in those paper towels do you think is getting the water to travel across? Well, there's a scientific term for that. Capillary action. So capillary action works by pulling up, defying gravity, and pulling up water from one cup and transferring it over into another cup. Kind of like slurping through a straw. So you have your paper towel. Your paper towel is made up of a bunch of little fibers from plants called cellulose. So you have cellulose fibers, which are these little green squiggly guys, indicating little fibers. And then you have these little white or little blue dots. Those are your water molecules. there's very strong cohesive forces that make the water molecules combine together. So we have these little water molecules going up through the cellulose fibers. Well, now there's even more forces at play. We have adhesive forces of the fibers that want to grab the water molecules and push them as far up as they can go and pull them through the fibers. So like these fibers pull that water molecule, and then that fiber pulls it all the way up through. So like each little fiber does its job to pull it all the way up and over. So even though we have gravity coming down saying you don't want to go upwards, the forces are so much stronger than gravity to then pull it up and over. So that's how we get the water from the full cup into the empty cup. So can you guys think of anything else that might use capillary action to pull something up? I mentioned a straw, which is kind of, but when you're using your mouth to make it happen, it's not really the same, but you can put your thumb over the end and let go and it pulls it up, which is kind of like capillary action. There's a lot of different examples out there. What about a water balloon fight? Have you ever been in a water balloon fight? I bet you have. Have you ever gotten a water balloon thrown at you and your shirt gets wet? You're like, oh, I got wet. But then you realize it travels and it expands throughout your shirt. So a little spot now becomes a big spot. Well, that's capillary action, because all our shirts are made up of fibers too that help pull the water out. So it's pulling out whenever you get hit with a water balloon. Another one is if you plant flowers or if you see trees out in nature, they also use capillary action. So you have your ground, there's water in the ground, and then all plants have little roots. The roots go into the dirt, pull up the water molecules, and goes up into the tree to help it stay green and thrive. So that's capillary action in action. So that is pretty neat. So far we've learned about primary colors, secondary colors with the color mixing, and capillary action. But don't think you're done yet. We have one more thing. What do you think is going to happen with the water levels? Do you think all the red's going to go into this empty cup along with all the blue, and then, oh no, we have an overflowing cup and a mess on hand? Or do you think just a little bit of the blue will go into the empty cup with a little bit of the yellow to make green, and then it will just kind of stop? It'll just find its happy place. What do you think is going to happen? Well, what's going to happen is they're going to form equilibrium. And equilibrium is when the two of them become equal. So when this cup becomes the same as this cup, becomes the same as this cup. So all 6 cups will have the same water level. And this is because it wants to achieve balance.
Sharon says it will even out.
Yes, exactly, Sharon. It will even out. So it's going to balance itself out and be even, because everything wants to become even. And it wants to go from high to low. So once it's even, there's no high to go to low. So that's what it's going to do. So, sorry, behind my 3, 2, 1. We have cups that have been sitting in my kitchen for a while that have come to equilibrium. So you can see the red and the yellow mix to form this pretty orange, yellow and blue mix to form this pretty green, and blue and red mix to form purple. And as they go to equilibrium, you can see the colors wanting to go back and forth. So some of the red is starting to travel up the yellow, and some of the green is traveling up, or some of the, I guess, yellow is traveling up the blue. So you're seeing some of the other colors mixing because it's trying to establish its happy point where it's at equilibrium. So eventually, if we let our experiment we just started today sit for maybe like another hour or so, eventually it will too get to equilibrium, which is pretty cool. So we've done this experiment, but I want to give you a challenge. So repeat this experiment, but I have 3 different variations for you to try. Change up the water level, the volume in the cup. start with a little bit more in one cup, a little bit less in another cup. How does the water level change the experiment? Does it take longer or shorter to get to the empty cup? You do it and you let me know. Try different brands of paper towel. Not all paper towels are as absorbent or have as much cellulose fiber. So try different paper towels. These are Bounty paper towels. There's like Kroger brand, Target brand, Sam's brand, Costco brand, Walmart brand. I mean, there's tons of paper towels out there. And they all have like their own different designs that are supposed to help with absorbency and everything. So do different paper towels and let me know. Does it change the rate at which the capillary action happens? Also, try different paper products. Toilet paper, computer paper, newspaper would work. And let me know how that works, because all of these mediums are made up of cellulose as well. Talked about the height. So the height of water in the cup, different brands of paper towels, and then different paper products used. So do those 3 things, and then post in the comments what you see. What are your observations? And then let me know why you think that's happening. So you're really becoming a researcher in the STEM field. So these are the 3 questions to ask as you're doing these. What do you think will happen? So before you even start, how does changing the water level impact things? What do you think will happen? Will it cause it to go faster? Will it cause it to go slower? And then observe what actually happened. Take notes. Watch it over time. You can even use a timer and see, okay, if I fill it up high, it only takes like an hour to get over to the other cup. But if I only fill it like an inch high, it takes like 2 hours to get over. So write down your observations and then try to explain what happened. Why do you think that happened the way it did? So again, you can change the brand of paper towel, you can change the height of the water, and you can do different paper mediums. So you can use newspaper, computer paper, what other ones I have written down? Toilet paper, I may have already said that. Yeah, different paper products, see how they behave. You do watercolor paper versus like a cardstock versus printer paper. I don't know. You try it and you let me know what happens, because I've not done this. And then answer these 3 questions. What do you think will happen? What actually happened? So that's the observation. So what do you think will happen? That's your hypothesis, if you remember the whole scientific process. And then what actually happened? Observation. And then how do you explain what happens? Summarize your results.
Someone gave you a thumbs up.
Thumbs up. Awesome. Hope that thumbs up means you're excited and you're ready to try this. So those are the 3 things. And so I hope you accept your challenge, and I can't wait to see what you guys have. Feel free to share pictures, videos, whatever you have in the comments on this video, and we'll be monitoring it and seeing what you guys have to say. I think I have about like 5 minutes here. So I know we are having some technical difficulties at the beginning, so I just wanted to let you all know that we're here today with GE Aviation doing STEM camps because we can't be at Camp Butterworth this week. Which we could be. We miss seeing you guys. We usually do catapults, microscopes, a science experiment with chemistry. Last year we did, I think, bath bombs. We've done slime. We've done all sorts of things. Each year we try to do something different. And then microscopes and catapults and 3D printing, I think. An egg drop. We've done so many things over the years I've done this, and I think I've done it for like, I don't know how long we've done this for, 3, 5 years? It's been a while. So we've done a lot, and we try to change it up to keep you girls entertained. So since we're not able to do Camp Butterworth, we're doing, I think it's an 8-week series on different STEM activities every Friday at 1 and 3 o'clock. So last week we did airplanes, this week we're doing the walking rainbow, and next week we are doing volcanoes. So I think you should have your supply list. It's posted out there. Baking soda, vinegar, a little plastic container, dish soap, and food coloring. Pretty simple. Hopefully you have them all on hand and you don't have to go out to the store. But that's what we'll be doing next week. And my name is Brittany, and I'm with GE Aviation. I'm a materials engineer who makes things and then breaks them and then reports on how well they behaved. So it's pretty exciting, and we build jet engines. So if you're interested in what people do at GE as well, tune in each week because we have many different people presenting, and they can give you their backgrounds as well, and you can see the vast array of stuff you can do in the STEM field. So with that, I appreciate you guys tuning in and learning about rainbows, and I'm looking forward to seeing what your results are after you take the challenge. So thank you all, and we'll see you later.